So let's go over some basics of measuring angles. So with this, we'll get some terminology. We'll also get some tips and tricks for how to kind of visualize these angle measurements once we're on our XY coordinate system. So an angle is a measurement, and it's between this initial side and terminal side. So these are rays here. So rays start at a vertex and then continue on forever. So we have an initial side and a terminal side, which determines that movement right there. And that measurement in there would be our angle measurement. Now, in terms of notation, we're going to use a symbol for angles that's called theta. So it's a circle, a little line in it. And out loud, we say theta. It's just a symbol that relates to angles and their measurements. Now, going to our coordinate system, which is where we're really going to be working with our angles, it would look like this. And for standard position, that means our initial side is along this positive side of the x-axis. So if it says standard position, that's where we're at. And then from there, we can move in a counterclockwise motion like we're seeing here. So going the opposite direction of a clock. And that means we would have a positive angle measurement. If I made a different terminal side, let's say we were down here, and I showed the motion going in this direction, which would be clockwise, that would mean our angle measurement would be negative. So what we want to do now is seeing this initial side in the standard position, and more importantly, seeing where the terminal side ends up. How can we visualize what these angle measurements actually are without the use of a protractor or any other measuring tool? Visually, where are these angles landing? So what we're going to use is the fact that to make a full circle is 360 degrees. So what we can start with first is just how the quadrants divide up that 360 degrees. So where this would be 0 degrees, where our initial side is the same as the terminal side. It can also represent 360 degrees. All we would need is a little arrow in there to show that we went a full circle, and that would represent 360 degrees. So what we're doing with our quadrants is we're taking that 360 degrees and dividing it up by 4, which would give us 90 degrees. So we have these units or increments of 90 degrees that we're working with. So to move just kind of one of those quadrants, that would be a measurement of 90 degrees. To move 2 of the quadrants, so again, our initial side is always right here. That means we travel 180 degrees. And then to get to the y-axis on this negative side would be 90 plus 90 plus 90, which is 270 degrees. And then if we went one step further, that would take us to our 360. So these are 4 very important degree measurements to definitely memorize, or at least know how you can find them, knowing it's increments of 90. Now, there are some other increments that we're going to focus on in this class, and the more you can practice these, the better. Like, I'll walk you through them and talk about how to find these measurements and visualize them, but the more you can practice these, the better, because it'll help in the future when we're working more with these angle measurements. So 45 degrees. If we think about increments of 45, if you visualize our 90 degrees like this, what we're doing is essentially cutting that in half. So what we have here is a grid, and this grid, these kind of cuts here represent these increments of 15 degrees. So we like have 15, 30, 45, 60, 75, 90. So in terms of increments of 45 degrees, I could visualize this as 45 degrees, and then plus 45 degrees, plus 45 degrees, plus 45 degrees, plus 45, plus 45, plus 45, plus 45. So in terms of angle measurements, what we have here is 0 degrees. And this right halfway between 0 and 90 would be our 45 degree measurement. Then we would have 90 and plus 45 for 135, 180, oops, not 18, 180, 225, 270, 315, and then making the full loop to 360 degrees. So this is how we can visualize increments of 45 degrees. And really, it's just cutting up this full 360 degrees into eighths, or you can think of it as fourths of that 180 degrees and fourths of this lower 180 degrees. But the idea is kind of knowing where these numbers are landing. So the 0, 90, 80, and 270, those will never change. That's always the degree measurements there. What we just want to do is fill in the blank for some degree measurements between those, and using these idea of kind of these even fractions that we can divide up 360 into, because 360 is incredibly divisible. And we're going to look at a few ways to divide it up, and one of those ways is into eighths. So these numbers, again, we just want to be able to visualize where they're landing. And even though if you don't memorize that 225 is exactly there, the idea of knowing if you took 180 plus a 45, so moving halfway between there, then you could get to that 225. So it's more about mapping to these pieces rather than memorizing the actual numbers. Let's look at increments of 60 degrees. So how I'm going to think about this is if I took that 180 and 60 degrees is coming from a third of 180. So if I have my 0, I have my 180, what I'm doing is dividing this up into 3. So this distance that we're traveling here, I'm cutting that up into thirds. And what that will look like is we'll have an angle measurement there. And you could also find that by, again, these increments of 15. So 15, 30, 45, 60 would bring us right there. And then I would want to move another 60 degrees. So that right there is dividing up my 180 degrees into thirds. And then I'm going to do the same thing down below as well. So I have 0 degrees plus 60 degrees plus 60 degrees plus 60 degrees, plus 60, plus 60, plus 60. So notice with these increments, we aren't landing on 90 or 270 at all. We're kind of skipping over those, but we still have our 0, 360, we still have our 180, and then we're just seeing these measurements that are coming through here. So we're seeing these measurements close to the other ones that we saw before too. We're just in a slightly different position to get these extra numbers to help us guide through. So to go into more detail with this, what if we took 60 and cut it in half? What if I wanted to know this measurement right there? And same thing between 60 and 120, and same thing between 120 and 180. And that's going to give us these increments of 30 degrees. So this increments of 30 degrees kind of takes what we did for 60 and gives us even more detail by cutting in half and cutting in half and cutting in half. So we have our 0 degrees, and now we're going by 30 plus 30 plus 30 plus 30 plus 30 plus 30 30, 30, 30, 30, and 30. Yeah, and 30. Okay, there we go. So you can see these numbers that we keep seeing pop up. There's our 90, 180, 270. Those are completely the same. We can also see our 60, 120, 240, 300. And then in here is also our 45 and 135. Is just visualizing these different ways of kind of cutting up our circle, even though we're not drawing our circle, but really cutting up the coordinate system with these angle measurements. It'll help us graph these rays that we want to, given a certain angle measurement. How can we find it based on knowing how it divides up either by eighths or by sixths or by twelfths? So this will help us get around, and using this kind of grid system where we can see how these angle measurements come through. So the idea being, if I wanted to graph positive 135 degrees, sure, I could just reference this and you're like, okay, there's 135, so it's halfway between 90 and 180. But without having to keep referring to these, what I could do is visualize that, well, we have 90 degrees in there. So if I know I'm going to cover 90 degrees as a distance, what then will I have to do to go further? And I would need an additional 45 degrees. So what this will help me do is cover the 90, and then I would know that I need to go halfway between my 90 and 180, and that would give us our terminal side right there. Then for negative, so we have our initial side. So negative, we'd be going in a clockwise direction, and negative 60, well, I could visualize, well, there's negative 30, and negative 60 would just be another one of those. Or you can imagine if you have these 90 degrees, it's like you're dividing it up by thirds, and we're covering 2/3 of that distance. So with this, even though it's angle measurements, there are these ideas of fractions and dividing up this 360 degrees in a way to navigate around. So let's practice this. What we're going to do is sketch some of these angle measurements using this grid and finding these values. Now 60 degrees was an increment that we talked about, and we saw how it came through here. And if it helped, if we knew it was something divisible by 60, we could think about all of them that come through. But really just going to 60 degrees, it's positive. So I know I'll be going in this direction, and then I would go until that line right there, which is our measurement for a positive 60 degrees. And I would just draw our line right there. If you wanted to think about in terms of increments of 30 degrees, you could do that too, thinking about these lines here, and that you would have 30 and 30 again, and that would take you to 60. Same idea. 390 degrees. Now, this is positive, so I know I'll be going in this direction. And what I can tell is that we're going to make a full 360 degrees. And then I'm going to go a little bit further. So what we can do is a little bit of side work here of, okay, I know I have 390 degrees, and I know I'm going to cover 360 degrees of that. So what do I have left over once I do that full revolution? And we would need to go 30 degrees further. So what I'm going to do is I can think about how we're going to end up back to our initial side right here, and then we need to go an additional 30 degrees, which comes through right here in our line. And if it helps, you could think about dividing up that 0 to 90 into thirds, and we just need 1/3 of that. So we're going around, we make a full revolution to 360, and then I'm going to keep going until I reach that side to go a further 30 degrees. So that represents 390 degrees, and our line would end up right there. Now, visually, just looking at this line here, looks like we're just graphing positive 30 degrees. Like here, there's 30 degrees. And that's true. Graphically, they look the same. What's important is recognizing how the line moves to show that we did a full revolution beforehand. These are called coterminal angles, and we'll talk about that more in the next video. And that 30 degrees and 390 degrees relate to each other in a special way. All right, let's go up here. So negative means we're going to move clockwise. So again, our initial side is always right there on our x-axis on the positive side. So negative 135, what I could do is think about how I know I'm going to reach 90. This number is larger than 90. So what I want to know is how much farther do I need to go beyond 90 degrees? So I could do is take 135 and just think about what's left over after we cover 90 degrees. And we're going to need an additional 45 degrees. So I'm going to go 90 degrees, and then I'm going to end up in this quadrant here. And then I just need to visual my 45 in that side there. So we'll have 90 plus 45, and going in a clockwise direction makes it negative. So there's our negative 135 degrees, and there's my line to show where we ended up. negative 480 degrees. So I know it's negative, so I'll be going in a clockwise direction. And 480 is larger than 360, so I know I'm going to make a full revolution. So to help out with my numbers, I'm just going to think about, okay, I have 480. What happens when I cover that full revolution of 360? How much am I going to have left over? And I'll have 120 left over. So what I've done so far is I've gone a full revolution, and then I need to go 120 degrees further, which means I know I'm going to make it past this 90 spot. So I'm going to do to help out is take out those 90 degrees to see what's left over then. So I've pretty much gone to here, and I know I need to go 30 degrees further. So if I think about my increments of 30 degrees in that grid there, what's going to happen is to go 30 degrees further, I need to get to that spot right there. So this would be going 30 degrees, 60 degrees, 90 degrees, and we just needed an extra 30. So my line is going to go right there. And just need to note the angle measurement was negative 480 degrees. So with these, it's just a matter of getting the direction correct and then thinking in terms of these increments that we talked about in terms of 45s, 30s, and 60s.